Welcome to The Explainer. Today we're tackling a concept that, honestly, shapes just about everything, from the news you read to the products you use every single day. It's called sampling. It's this idea of seeing a huge picture by looking at just a tiny piece. And as we're about to see, getting it right is absolutely crucial. But getting it wrong? Well, that can be a total disaster.
This quote from Morgan Housel just hits the nail on the head, doesn't it? It perfectly captures this basic challenge we all face. Our own little slice of reality, our personal experience, it feels like the whole story. But in reality, it's just one tiny data point in a sea of billions. You know, we all view the world through a kind of personal keyhole. And every single piece of data we see, every statistic, every news report, it's exactly the same thing. It's a tiny, real, but totally incomplete glimpse of a much, much bigger truth. Look, the problem isn't that we use samples because we have to. There's no other way. The real danger is when we forget that it's just a sample. So how do we widen that keyhole? How do we get a better, more accurate view of what's going on? Well, it all starts with a really simple but incredibly powerful analogy that gets right to the heart of what makes evidence trustworthy in the first place. And this is where the idea of sampling comes in. You know, the famous pollster George Gallup, one of the pioneers of this whole field, had the perfect way of explaining it. He compared it to tasting a pot of soup.
Think about it, right? You don't need to drink the entire pot of soup to know if it needs more salt. One spoonful is all it takes. But, and this is the part almost everyone forgets, that only works if you've stirred the soup first. Seriously, most of the biggest mistakes in data don't happen because the sample was too small. They happen because nobody bothered to stir the soup.
Okay, so this whole soup idea, it leads us to something I like to call your new data superpower. It's a single question that acts like a mental filter, and it'll help you spot bad data and weak arguments from a mile away. This right here, this is the single most important question you can ask. It makes you hit pause on the shocking headline and actually check the foundations. You're asking, wait a minute, is this statistic telling me something real and true about the world? Or is it just telling me something about the kind of weird, specific way these numbers were collected? So how do you actually use this? It's a really quick mental checklist. First, what's the claim they're making? Okay. Second, who did they actually talk to get this data? Then, and this is key, think about who they didn't talk to. What's the gap? Who is missing from this picture? This simple process shifts your focus away from the flashy conclusion and puts it right where it belongs, on the quality of the evidence. All right, let's put this to the test. We're going to look at a kind of rogues gallery of the most common ways sampling goes wrong. Think of these as the unstirred soups you'll start seeing absolutely everywhere once you know what to look for. First up is a really sneaky one that's incredibly common. I call it the silent graveyard. This is the bias that comes from only studying the winners, the successes, or the survivors, while completely ignoring all the failures that might be telling a very, very different story. And to really see this bias in action, let's dive into a famous puzzle from World War II. The US military wanted to add more armor to its bombers to protect them. So they looked at all the planes that returned from combat missions, and they mapped out where all the bullet holes were. So the question is, where would you add the armor? The obvious answer seems to be, put it where all the holes are. But was that right?
The brilliant insight came from a statistician named Abraham Wald. He realized the data they had, the bullet holes on the planes that made it back, was actually misleading. He saw what was missing. He saw the ghosts in the data, the planes that never came back. He concluded that the military should armor the places with no bullet holes, the engines, the cockpit. Why? Because those were the places where, if a plane got hit, it wasn't making it home. The lack of bullet holes there wasn't a sign of strength. It was the mark of a silent graveyard.
Next up, let's talk about a very modern and really dangerous assumption. This idea that a massive data set is automatically an accurate one. We hear big data and we think better data, but that is just not always true. Let me take you back to 1936. A magazine called The Literary Digest ran one of the biggest polls in history to predict the presidential election. And I'm not kidding. They surveyed 2.4 million people. That's an absolutely enormous sample, even by today's standards. And their prediction? It was spectacularly, epically wrong. So what happened? Well, their sample, even though it was huge, was pulled from phone books and car registrations. But this was the Great Depression. The only people who had phones and cars were generally wealthier. They completely missed the average voter. This is the ultimate proof that a small, well-chosen, representative sample is always better than a massive biased one.
Quality beats quantity every single time.
Okay, our last bias is one you see every single day. I mean, you probably saw it 5 minutes ago. It's all over online reviews, social media polls, comment sections, anywhere people choose to speak up.
This is what's called voluntary response bias. The people who have super strong feelings, the ones who either absolutely loved a product or totally hated it, they're the ones motivated enough to leave a review. The huge silent majority in the middle, the people who thought, it was fine, they just move on with their lives. So the average rating you see almost never reflects the actual average experience.
So these aren't just abstract ideas or fun historical stories. These sampling mistakes have profound and sometimes pretty dangerous real-world consequences that can affect our health and safety.
I love this quote from Caroline Criado Perez because it sums it up perfectly. Big silences. That's the danger. When our data systematically ignores huge groups of people, the world we build based on that data is incomplete, and it can be actively harmful.
And this is not theoretical stuff. For decades, car crash test dummies were based on the average man's body. The result? Cars were systematically less safe for women. A lot of crucial medical research defaulted to using only male subjects, leaving massive gaps in our understanding of how drugs and diseases affect women. The lesson here is so clear. When our data has blind spots, the world we design inherits those exact same blind spots, often with really serious consequences.
So, the next time you see a statistic, a poll, or a study, don't just accept the number they give you. Ask yourself, what story is this data not telling me? Who was left out of the room? Remember those planes that never came back from their mission? And always remember to stir the soup, because often the most important truths are found in the silences.